Let's take a look at writing an equation through the line and point slope. This is just a second example of the same thing. Then we're going to do what Mickey was asking about with rewriting in slope-intercept form. So this is exactly what he was talking about. So as we make this happen, let's look back at our form. Until you're used to it, just keep writing it out. Y minus y1 equals m times x minus x1. All right, Kyrie, walk us through this.
All right, so you're going to have
Y minus
9
yep,
equals
perfect. So you take y minus 9, 9 is y2, 3 is x, 9 is y1, this is x1, x1, y1, and you're literally just plugging in the numbers where they belong. So this is done for this part of the question. Then we need to rewrite it in slope-intercept form. But what is slope-intercept form? You were okay. What you were saying was you were saying the slope formula, but slope-intercept form is y equals mx plus b. So this is where he was talking about you're going to need to distribute. Okay? So we're going to take this down here, and we're going to go ahead and distribute. 2/3 gets distributed. You're going to like this. This is much easier than figuring out, like plugging in, figuring out b, and then plugging it back in. 2/3 times x is 2/3 x. 2/3 times 3 is 2. Okay, let's make sure everybody gets that. 2/3 times 3, cross cancel, that's where your 2 comes from. Now you're putting it in slope-intercept form, so you need to add 9 to get y by itself. You're trying to solve for y. So y equals 2/3 x plus 7, and we're done. Okay, super, super nice, elegant process here. Rewriting in slope-intercept form, putting it 2/3 x plus 7, and it's just plain done with that. Yep. All right, now we're taking a look at what we do when we have 2 points rather than a point and a slope, but we're still writing point-slope form of an equation. So what are we missing for the point-slope form of the equation when we have 2 points? The slope. So we have to find the slope. So we do, this is where your formula comes from you wanted to do a minute ago, Maya. y2 minus y1 over x2 minus x1. I can't guarantee one way or another. I don't believe you're graphing on the homework. But let's stay focused on this right now. So we have x1, y1, x2, y2. So we plug in the values. Courtney, plug in what are the values then?
8 minus 5.
Good. Plus 3 because it's minus negative. We simplify this, we get 3. Okay, and we would probably more likely write that as negative 3/4. All right, now all you have to do is plug it into your point-slope form, which is y minus y1 equals m times x minus x1. All right, so Mary, what's y1? 5. And what's m, Mary? Negative 3/4, that's what we just solved for. And x, and we need the x1 part to be in there. Minus negative 3, but we won't leave it like that. We'll turn it into x plus 3. And if you go directly to x plus 3, because you already understand minus negative, that's perfectly fine. So y minus 5 equals negative 3/4 times x plus 3. And that's your slope-intercept equation. What I'd like you to do is I would like you to try this one on your own. I'll give you a couple minutes, and then we'll reveal it and show you what the answer would be. Look. All right, let's take a look at the answer. 4 minus negative 2 gives you 4 plus 2, which is 6. 3 minus 5 gives you negative 2. So 6 divided by negative 2 is negative 3. Then we have your blank equation. The y's and the x, the y and the x stay y and x. Minus negative 2 turns into y plus 2. Negative 3 is your slope. Minus 5. And that is how you finish up that problem. Minus 5. They're all minus, but y minus negative 2 gives you y plus 2.
So you wanted us to go
Right, because it says right in point slope form an equation. So the directions tell you what to do. If you're writing an equation, you have to write the equation. If it says find the slope, then you find the slope. So this is the actual equation. If you solved it and you graphed it, then you would, we would have that thing that we're doing. All right, so linear equations also can be written in standard form. Standard form should look familiar to everybody. AY plus B, AX plus BY equals C, absolutely. The A, B, and C are all integers. And what are integers again? Numbers. Numbers on a number line, can they be the decimals or fractions that you find on the number line?
Yes.
Nope.
No.
Real numbers or anything can be found on a number line, but the ones that go by ones, the positives and negatives going by ones, those are the integers. So we can't have any decimals or fractions in these three spots when you finally have solved the problem. So what we're going to do is we're going to take a look at a couple of problems where you're actually putting the equations into standard form. Okay, so linear equations can be written in standard form. AX plus BY equals C. A, B, and C will have to be integers by the time you're done. And we're going to look at writing the equations into standard form. And so the best way to do that is actually to go about doing some problems. I still have that formula on this one. Write each equation in standard form. AX plus BY equals C. So what we need to do is we need to go through the process of doing these, putting these things into the right format. So we're trying to get the x and the y on the same side of the equation and the number on the other side. So for this one, all right, how do we start, do you think? Okay, so let's move the 3x over. So minus 3x, minus 3x. So we have negative 3x plus y equals negative 5. Are we there yet? We are actually there yet. We got there. Negative 3x plus y equals negative 5. A is negative 3. B is 1. And C is negative 5. So that one's done. Nothing else to do on that one. We have fractions. Fractions take a little bit more time. Same basic beginning. What do you do to start? We're going to move the 2/5 x over. So add 2/5 x to both sides so they'll cancel. 2/5 x. So we have 2/5 x plus y equals 3. This is not done. Why is it not done? Because we have a fraction. So anybody know how we're going to get rid of the fraction? Multiply by 5. Take the denominator and multiply everything by that denominator. So when we do 5 on this side and do times 5 on this side, we get 15 over here. 5 times 2/5 is how much? 5 times 2/5 is 2. There it is happening. Cancels out, we get 2x. And then 5 times y is 5y. So this one's done right here. Okay. A is 2, B is 5, C is, okay, beautiful. So the goal is always to get x and y together and whatever numbers onto the other side. Then you've got it in standard form. We have just one more. Just one more. Ready? Nope.
Yay.
It's this one. It's a decimal. So once again, we're going to try to handle this so that we get x and y on the same side. So same process. First step would be to move the x. We're going to subtract 3.5x. So we have negative 3.5x plus 1y equals negative 7.2. But we have decimals. That's a problem. Anybody know how you're going to handle the decimals? So we have, if you were to read this decimal and you read it like the old-fashioned way, you wouldn't say 3.5, you would say 3 5 tenths, right? Because this is the tenths place. So you check and you figure out what the furthest decimal place is that's in there and multiply by that number. So this is the tenths place. We're going to multiply everything by 10. Multiplying by 10. And we'll see why in just a second. Yes. All right, so when you multiply a decimal times 10, all it does is it moves the decimal place over 1. So this will be negative 35x. And that will be plus how many y? 10y equals negative 72. Because it moved the decimal point over 1. Multiplying by 10 should not be a big deal. It's definitely not calculator work. Multiplying by 10 just moves the decimal place over.
So your final answer can't be decimal.
Right. Can't be any decimals or fractions in your final standard form answer that we're looking for. You can have negatives, but you can't have any decimals. Okay, good job.